State-of-the-art technology, innovative business strategies, behind the scenes, insights from cutting-edge users around the globe on 21st Century Business.
With energy consumption and conservation being key issues today, we feature a new technology called the OAM Purger. This technology is an important innovation in today's industrial, commercial air conditioning, and refrigeration industry. Now let's take a look at the OAM Purger.
The OAM Purger regains chiller capacity and can save a chiller owner thousands of dollars per year in energy savings. This oil, acid, and moisture purger for existing chiller applications can save approximately $1 to $4.3 billion a year in North America. There are an estimated 180,000 low-pressure centrifugal, high-pressure centrifugal, and high-pressure screw chillers located throughout North America, and this number is growing. The patented OAM Purger can save approximately $6,000 to $24,000 per year per chiller. Multiplying the conservative estimates of $6,000 to $24,000 per year times the estimated 180,000 applicable chillers, and the result is obvious. If every chiller in North America had an OAM Purger installed, the energy savings to North America as a whole would be a phenomenal $1 to $4.3 billion or more per year. And chiller owners will be pleased to find out that the cost of the OAM Purger can usually be recovered within 1 to 2 years, and in some instances, in just 3 to 4 months. It is also important to note that in the long run, the OAM Purger will assist in decreasing fossil fuel emissions and greenhouse gas emissions by decreasing chiller system energy consumption. Oil entrained in a chiller's refrigerant charge unnecessarily costs owners thousands of dollars each year in wasted energy, along with causing significant decreases in chiller system capacity.
It's a serious issue for the HVAC industry. There are thousands of chillers installed around the United States and around the world. A lot of them have too much oil and they're costing energy. We're talking about large chillers here that you find in hospitals, industrial processes, factories, universities, government buildings, basically the big, tall, large buildings with a large load.
Now, the technology exists to improve their electrical consumption efficiency, regain chiller system capacity, protect the environment, and save each chiller owner thousands of dollars per year per chiller in energy savings. Oil enters the chiller's refrigerant charge as the refrigerant is circulated through the chiller's compressor. On low-pressure centrifugal chillers utilizing R11, R113, or R123, and high-pressure centrifugal chillers utilizing R12, 22, 134A, 500 series, to name a few, the oil is used as a lubricant and assists in cooling the centrifugal compressor, and it seeps through the compressor seals and becomes entrained in the refrigerant charge. Oil inevitably finds its way into the refrigerant charge. Basically, oil finds its way into the evaporator, where it mixes with refrigerant and thus degrades system efficiency and capacity. This occurs when the evaporator tubes become coated with oil, creating a thermal barrier, and the heat transfer efficiency is retarded and drastically reduces the cooling effect. This animation represents what is occurring inside the chiller on one of thousands of tubes. As oil concentration in the evaporator increases, it degrades efficiency. Clean refrigerant is more efficient than refrigerant mixed with oil, acid, and moisture. And this buildup also allows oil to cover the coils, acting like insulation, and thus retarding thermal transfer as indicated by the red arrows. Once the OAM Purger is installed, it removes the oil from the refrigerant, and this cleaner refrigerant washes the oil from the tubes, thus improving thermal transfer, regaining chiller capacity, and saving energy. Although it is common knowledge that oil buildup occurs, the significant impact on the system's capacity and extreme energy costs are only now being realized. The following studies note the importance for chiller owners to recognize and allow their service contractor to address this problem. ASHRAE performed a study titled Effects of Oil on Boiling of Replacement Refrigerants Flowing Normal to a Tube Bundle, Part 1, R123, and Part 2, R134A. As discussed in Part 1 of this study, conclusion: flow boiling results have been obtained for the low-pressure refrigerant, enhanced boiling tube in the presence of R123. The effects of the oil on local and average boiling heat transfer coefficients have been given. This enhanced tube shows a marked decrease in heat transfer with the addition of even a small amount of oil heat loadings. Even at 1% to 2% oil by weight, the heat transfer coefficient is reduced by 1/3 from its no oil baseline. At a substantial oil content of 5% to 15%, a 40% to 50% reduction is noted. Part 2 of this study obtained a similar conclusion. Flow boiling results have been obtained for a newer enhanced boiling tube with R134A. The effects of oil on local and average boiling coefficients have been given. This enhanced tube shows a decrease in heat transfer with the addition of even a small amount of oil throughout various heat loadings. Even at 1% oil by weight, the heat transfer coefficient is reduced by 25% from its no oil baseline. At higher oil content, a 30% reduction has been typically measured. The attached graph illustrates the findings in an additional ASHRAE study titled ASHRAE Research Project 601-TRP, in which refrigerant samples were taken from 10 operating chillers and analyzed for oil content. All of the chillers were found to contain excess oil in varying amounts, from 3%, enough to significantly degrade performance, to as high as 23%. While studies do show some slight variance, they all strongly support each other in the fact that oil does find its way into a chiller's refrigerant charge and significantly decreases chiller capacity and increases the amount of energy required to run the chiller.
Well, oil migration occurs in essentially all products because we use oil in a compressor to lubricate the bearings primarily and to cool the bearings. Ideally, you'd like to keep the oil in the compressor, but in the real world, a portion of it gets out, gets into the system, circulates through the heat exchangers, and in simple terms, it'll end up in the evaporator, which is the coldest spot. It starts collecting in there, and that's when we start having the detrimental effects. Oil is a contaminant. It's where you don't want it. What it's doing is obstructing heat transfer. So it's by coating the tubes, it's preventing the expected amount of heat transfer. It reduces the capacity, which really requires you to spend more energy. So it's costing you energy is the bottom line.
How the OAM Purger works. The Oil Acid Moisture Purger is designed to continually clean oil, acid, and moisture from a chiller's refrigerant charge and return the oil to the chiller's compressor lubrication circuit, oil reservoir sump where it belongs. OAM Purger's operation of oil separation and refrigerant cleaning is accomplished via a unique process utilizing the properties of gravity, heat, and pressure exclusively to function. The OAM Purger does not utilize mechanical pumps of any type. The OAM Purger's oil separation and refrigerant cleaning is accomplished by repeatedly extracting from the chiller evaporator batches of oil-contaminated refrigerant, approximately 10 to 20 pounds per each cycle. The oil-contaminated refrigerant is then heated via a distillation heater, which causes the liquid refrigerant to vaporize or boil off. The refrigerant is then distilled back to the chiller evaporator, leaving the oil behind, thereby distilling out contaminating oil. When the temperature of the accumulated distilled oil reaches 145 degrees Fahrenheit, it is essentially pure oil, wherein it is automatically returned to the chiller's oil reservoir or sump. Because the purger operates 24 hours a day around the clock, regardless of chiller operating status, the refrigerant is permanently maintained in a virtually oil-free state. This is true even in those situations where significant oil carryover occurs due to excessive oil seal wear. The OAM Purger is a totally passive device that operates independently of the chiller and has no effect on chiller operation other than cleaning the refrigerant, saving energy, and increasing capacity. It is important to note that the cost of running the OAM Purger for the year is approximately equivalent to running a 200-watt light bulb for the year.